define the indifference curve here. So for that, what will we do? We will take three cases here. So for optimality, what will we do? So we compare the results with the prices. So case 1 will be Px upon Py if it is greater than 1. Okay. So since we have this indifference curve, we also need to construct the budget constraint. So for this region, and let me draw it like this. So we have good x on the horizontal axis, good y on the vertical axis. If the slope of the budget line is greater than 1, so it will be a steeper budget line. Okay, and let's draw this 45-degree also, this line. Now what will be with the given budget line? Consumer will try to reach to the highest possible utility or satisfaction. So let us draw some indifference curves here. So first will be like this. Let us suppose this, then we will get this indifference curve, and let me try to draw it perfectly or correctly. So another will be this one. Okay, so here you can see the indifference curves are intersecting at these points. So another indifference curve will be like this, but it lies outside. So our optimal point will be at this point when the slope of the budget line is greater than 1. So what will be the optimal point here? So consumer will consume 0 units of good x and all units of y. So y will be equal to, what will be the y then? So if x is equal to 0, y will be equal to m upon py. So the optimal point will be 0, and consumer will consume all units of good y, so py. Okay, this is one case. Second case can be if the slope of the budget line px upon py, if it is equal to 1. Okay, what happens at that point? So let me try to draw the indifference curve for that also. So we have good x on the horizontal axis, good y on the vertical axis. So in this case we have this kind of budget line, and let's draw this also. Now in this case, so with the given budget line, consumer wants to reach highest possible indifference curve, satisfaction. So first indifference curve will be this. Okay, so it will not give him the maximum satisfaction. So we will take another indifference curve like this. Then another indifference curve will coincide with the budget line. It will be like this. Okay, so at this point what happens? Consumer will, since they coincide with each other, so we will have in this case what happens, and let us try to analyze. Consumer will choose any combination of x and y as long as x is greater than y. Okay, so any combination of x and y as long as x is less than y. Okay, that will be the optimal point. Now third case can be when px upon py is greater than 1, less than 1. Okay, so in this case what will happen? So let us take the third case also. We have good x on the horizontal axis, good y on the vertical axis. Again this time our indifference curve will be a flatter one, like this. Let us say this is our this is our budget line. So let us draw the corresponding indifference curves to reach the highest level of satisfaction. So we will have this kind of, this will be one kind of indifference curve, another can be this. So we will get this kind of indifference curve also. Okay, so here we get this point where the satisfaction is highest. So this will be a corner, sorry, this will be the interior solution here. Okay, if x px upon py is less than 1, okay, so this point will give us the demand function for good x and good y. Okay, so for that, how do we write the optimal point? So we will get what we call, since we know that x is equal to y, so let us plug it into the budget constraint. Since x is equal to y at this point, so we have price of x into x plus, let's write, since x is equal to y, let's write py into x is equal to m. So in this case we will get, let us take x common, we are left with px plus py is equal to m. That means consumer will consume m upon px plus py. This will be the demand function for good x. Likewise, demand function for good y will be equal to m upon px plus py. Okay, so the optimal bundle will be m upon px plus py and m upon px plus py. Okay, I hope I make myself clear in this video. Thank you.